Okay, hello, good morning, good afternoon, and good evening to everyone. Welcome back. Today I want us to just run through a number of questions on logarithmic and exponential functions. So look at the number of expressions, equations involving logs and exponential functions, more of equations, more of situational questions, and a number of things. So I believe in previous videos we talked about some of the rules involved in exponential functions and how we were able to use those rules to be able to solve various expressions and solve some of the equations. So today we'll focus more on the same worksheet 6. We'll just look at one or two questions in worksheet 6 in this video, and then I'll be able to create obviously maybe a separate video for applications later on. Yeah, so we'll start by, I'm sure you can be referring to your worksheet 6 BS140, the Copperbelt University BS140 worksheet 6. Yeah, that's the one 2025 we'll be referring to mostly. So I believe a number of questions we've tackled them physically in class. Yeah, so it's more like this is just more like a revision video, which for some of you. Yeah, so let's start by looking at question number 3 of your worksheet 6. Worksheet 6 2025. I don't know if my questions are visible on the screen there. Yeah, but the question says that we want to show that the function y equal to the natural log of x and y equals to e power x, show that they are inverses of each other. This is the question we're tackling on question 3 of worksheet 6. So remember, we're talking about worksheet 6. So I want to show that those two are basically inverses of each other. So you can be looking at your worksheet 6. That's the question where we're getting the question from. So we start. So basically, what are we looking at here? We're now going back to term 1, where we're talking about inverse functions. We're talking about inverse functions in term 1. So this is what we're going to embrace back again. So remember, in solving this one, we're going to recall the composite theorem when we're talking about functions, which stated that we said that two functions, so this is more like a revision for term 1, where we simply say that two functions, f and g, are inverses if and only if they are composites, meaning that f of g should be equals to g of f, and these functions should be equals to x. So if this rule is obeyed, two functions f and g, they are composites, the composite of f of g and g of f. If the two composite functions are giving you the same expression, which is equal to x, then you can conclude that the two functions are inverses of each other. So what are we going to show? We'll show the first part 4, and we'll show the second part golf. So if these two all give me an x, then we can conclude that they're inverses of each other. So what can we say? We can let f of x be equals to the natural log of x, and we can also let g of x be equals to e power x, so that f of g and g of f should give us x. If it gives us an x, then we can conclude they are inverses of each other. So basically, these are just composite functions. I'm sure we can remember how to come up with composite functions. So f of g means that in the function f, replace g, or evaluate the function f at g of x. So it means that in the function f, we are putting in g of x. So everywhere where there is x in the function f, where there is x, we have replaced with g of x. So this means that this is just a natural log of g of x. And this will be the natural log of what is g of x? It is e power x. So if I have fog, which is function of g of x equals to the natural log of e power x, what am I going to have here? Basically, the rules should start applying now. Natural log of e power x using the power rule. So using the power rule, what am I going to have? The natural log of e power x, the x drops down. So this is natural log of e power x is just basically the same as x, the natural log of e. And basically this natural log of e is basically a 1. Remember, natural log of e, it is a log, a special log which has a base of e. So if the base and the input are the same, the whole expression becomes 1. So if this is just basically equals to x, this implies that function f of g is now basically equals to what? Basically equals to like x. So what has happened? We had to let our function f of x to be the natural log of x. So where there was x, we replaced with g. So the g was now, the f was evaluated at the function g. So everywhere there was an x, I had to replace with g of x. So that when we simplify, remember the rules should be working here. The same exponential rules and logarithmic rules should be able to work out. So the first part has been shown that fog, or a function f of g, is equal to x. But is it true that g of f as well should be equal to x? Remember, if they're inverses of each other, both f of g and g of f should give us x. There are some cases whereby f of g produces an x, but g of f does not produce an x. It means that maybe there's a situation whereby f is an inverse function of g, but g is not an inverse function of f, because you cannot take it back to become f in terms of maybe it being not a one-to-one function, because basically for an inverse to exist is supposed to be a one-to-one function. I'm sure we talked about the number of those rules in term 1. So f of g is equals to x. What about g of x? I mean g of f. So g of f means that in the function g replace with f. So g of f means that in the function g replace f of x. So this means that in the function g, everywhere there is x, we replace f of x. So it will be e power f of x. This means that it will be e f of x is the natural log of x. And then what we could say here, recall the property which we said that if we have b log bx, the answer is always equals to what? X. So if this base here is as an exponential form, if this base here is equal to the base on the log, this base here is equal to the base on this log, the answer is just equal to the input of this power. So basically, e natural log of x, the base here is e and the base here is e, it means that the answer is just equals to x. These are one of the properties which we talked about under logarithmic functions. So therefore, our g of f, is basically equals to x. So basically, when you are proving in this case, make sure you state your rule and your property which you have used. Like in proving for fog, f of g, we mentioned that f of g should give us x. So as I was simplifying after placing gx in f, what was happening here, I had to embrace the power rule. I had to state it, what the power rule means. So from the power rule, that's where we obtained that x multiplied by natural log of e, having x multiplied by 1, which is giving me my x. So from here, what do I have? Fog, which is a function of f of g, and g of f are all giving me the same expression, which is x. So therefore you can conclude that these two functions are what? Inverses of each other. Okay, so now let's look at the second one. Question number 5, the same worksheet 6, which says that find the domain of the following functions. So remember, mathematics are about building up what we already know, and we are trying to build up something new. We've been talking about various functions in term 1, linear functions, exponential functions, rational functions, a number of them. So this time around we are just trying to build up and adding in two concepts here, the exponential part and the logarithmic part. But remember, these are already functions. From the same way we defined the domain, it's still the same definition of a domain even in exponential functions or logarithmic functions. Remember, the domain, we defined the domain as the set of input values. So remember, we simply said that the domain is just basically a set of input values, and these input values are our x values. This is what we defined the domain in our first term. So basically, if they ask you to say find the domain or maybe find the range is a set of output values. The domain is a set of input values. So now the question is, what is the domain? In other terms, that they are asking you to say what kind of values of x are going to define the functions given. So what kind of values of x are going to define the functions given? So now when it comes to logs, for log functions, so we have f of x, let's say, to be equals to the log of a certain bx. So for any log function, we're simply saying that the only values of x we can define this function given here, it is a situation whereby the domain for this function should be that x should be greater than 0. Those are the only values of x which can define this function. So what are we simply saying? This x here, which is our input, this x which is our input, this input here, whatsoever is in the input part, should not be 0, at the same time should not be negative. What does this mean? If, let's say, I was given f of x to be equals to the log of any, remember it's any base, the only focus is on your input. Let's say in the input here I had x minus 1, and then being told to find the domain of this function. If there's an x here, the domain will be x greater than 0, implying that any value of x greater than 0 is going to define this function. What values are those? We're talking about x being a member of from 0 way up to positive infinity. This will be a domain for this function. But if the input here has x minus 1, what do I mean? Meaning that my input here should not be 0, at the same time my input here should not be a negative. Meaning my domain here should be x minus 1 should be greater than 0. Implying that x should be greater than, when this one crosses the other side, becomes positive 1. So any value which is greater than 1 in this function, remember, despite the base, it can be log of base 2, it can be log of base 5, it can be log of base 1 over 2. The focus should only be on your input if you are looking for the domain. Meaning that x minus 1 should be greater than 0, x should be greater than 1. What is the domain which expresses this inequality? The domain is x, a member of from 1 way up to positive infinity. This is your domain. So your focus when it comes to logarithmic functions, either any log, it can be even a natural log, as long as it's a log function, just focus on your input. Meaning that your input should be greater than what? Greater than 0. to simplify for x. That's your domain. So now let's look at the log function there. So you need that on all logarithmic functions on question 5, as long as it's a log, just not to say the input should be greater than what? Should be greater than 0, and then solve for x for that inequality. Remember, the greater than, it means that what kind of expression is formed, this is an inequality, not an equation. Okay, so now let's see. This is the definition of a domain and some of the information you have to know under logs. So now let's solve the A part there. So we have that f of x is equal to the log of base 2 x over 4 minus x closed. What is the domain? We focused on the what? On the input. What is my input here? My input is x over 4 minus x. So for the function to be defined, this input here should be greater than what? Greater than 0. What does this give me? It is taking me to what? To term 1, where we are talking about such inequalities, rational inequalities. How are we solving rational inequalities? Finding the critical points or the critical values. This is how we are solving non-can. So if you cannot recall on how to solve rational inequalities, go back to the document on inequalities which we sent you. Should be able to revise through on inequalities. So this is irrational inequalities. So you find the critical values here. So these critical values are found by equating the numerator and the denominator to 0. So x should be equal to 0 and 4 minus x should be equal to 0. So basically, when it comes to such things, I always emphasize on something. This is a greater than symbol. It's not saying greater than or equal to, meaning that my critical point should not be equal to 0. The same x should not be equal to 0 because there's no equal to sign up. It's just greater than. So for this inequality to be satisfied, it means x should not be 0 and 4 minus x should not be 0. So the first critical value x should not be 0, and the other critical value when it crosses the other side, x should not be what? Should not be 4 when you solve for x there. So these are the two critical values. Now the question is, what will be your domain, or maybe what are the values of x in this case from these critical values? So from after you find your critical values, this is where we begin now to test your values. When you look at your number line, these critical values divides your number line on how many parts. So I'm coming from the lowest number here, with, let's say I can call this to be negative infinity. Who am I going to approach first? If I'm coming from negative infinity between 0 and 4, you're going to approach the 0 first. So the 0 will be approached first, and then from 0 you are going to approach a 4. From 4 you are going to go to the largest number, which is the positive infinity. This is how your number line is going to be divided, and this is how your intervals are going to be found. So from negative infinity to 0, this can be your first interval. So in short, the possible solutions for this inequality can run from negative infinity to 0. This can be the first possible solution. If this fails, it can run from 0 to 4. It's another possible solution. Or it can run from 0 to positive infinity. These are the three possible solutions based on our critical points. So how do you find which of these three is a valid solution? You test. From negative infinity to 0, there are a lot of numbers you can use to test for. Pick any number in between negative infinity to 0. For example, you can let x be equal to maybe negative 2. Negative 2 is in between 0 and negative infinity. Between 0 and 4, there are other numbers. Pick any number. You can say let x be equals to positive 2, because it's in between. Here you can pick as well another number. Let x be equal to 5. Use these numbers to test if the inequality will be valid. So if I get my negative 2 here, I punch it in there. Is my answer going to, which answer I'm going to have, is it true that the answer I'm going to have will be greater than 0? If the answer I'm going to have is greater than 0, then this interval is correct. The same applies if x equal to 2. If you punch it in here, if the answer you're going to have is greater than 0, then this interval is correct. The same as the last one. So if I'm testing for this one, put negative 2 in there, I'm going to have negative 2 over 4 minus negative 2. Is it true that this is greater than 0? So negative 2 there, this is 2 negative 2, this is a plus. So negative 2 over 6. Is negative 2 over 6 greater than 0? Ask yourself that question. So is negative 2 over 6 greater than 0? So what do you have? This is 0, not greater than 0. This is less than. This is a negative number. So it is not greater than 0. It means that this interval is a wrong interval to find my solution. Let's test for the second interval with positive 2. So if I put positive 2 there, 2 over 4 minus 2, is it greater than 0? I'm going to have 2 over 4 minus 2, which is a 2 greater than 0. Is 1 greater than 0? Yes. So this is a correct interval. This is a wrong interval. This is a correct interval. Test for the last one. What are you going to have? 5. 5 over 4 minus 5. Is it greater than 0? So I'm going to have 5 over 1, 5 over what? Negative 1, which is negative 5 greater than 0. Is negative 5 greater than 0? This is a wrong interval. So basically, if all your intervals are in ascending order, if the first interval fails, it means that the second interval will be correct interval and the last interval will be wrong interval. So this is how basically the rotation goes in. So from your testing, what are the values of x which is going to define this inequality? The only values of x going to define the inequality is the in-between inequality, meaning that the domain for this function is x member of which interval? From 0 to what? To 4. From 0 to 4. What kind of brackets are you going to use? You are going to use round brackets because you emphasize that x should not be 0 and x should not be 4. It means that it won't be square bracket, but it will be round bracket. This is your domain for the first function. Then from there now, look at the second part, B, which says that find the domain of f of x equals to 1 over 1 minus e power x. This is something very simple. Doesn't have a log. So if it doesn't have a log, that's not your focus. So it means that it will be very simple because you will have to analyze it again. What kind of a function is it? It has a denominator. Remember from the notes even we sent you, we simply mentioned that when you're finding the domain of a function, you look at the restrictions. The restrictions will always happen where? The restrictions will happen, number 1, in the denominator. Number 2, in the root. So restrictions, where you're able to use some of the things you can use restrictions. So the restrictions are the root. So if you have a root, a square root, it means that that's where the value, the restriction is going to come from, your domain. Anything under the root should not be negative. Revise the notes on domains. We simply mentioned this. The other point is we simply said is the denominator. We simply said that any function which has a denominator, the denominator should never be 0. So you look at this restriction, then you have those restrictions. The other restriction is the log. Anything which has a log in the input, we shouldn't be negative or positive, which we're just from solving for a. So these are the restrictions supposed to be able to be focusing on. So now this one doesn't have a log, doesn't have a root, doesn't have a denominator. What does it doesn't have the root, doesn't have a log. So what does it have? It has a denominator. It has an x in the denominator. So the denominator means that if you have if it has a denominator, it means that whatsoever is in the denominator should never be what? 0. So this means that my domain should be found from 1 minus e power x. This is my denominator. This denominator should never be what? Should never be 0. Then you are going to solve for x for that. So what am I going to have when it goes to the other side? What am I going to have? I'm going to have 1 is not equal to e power x. And what does this form? This form an exponential equation. So for the only way I can solve this, others would usually use log on both sides, natural log on both sides, but it's the same thing. If I have e power x and I have a 1 here, what does this mean? This means that this 1 can still be written as e power 0 is not equal to e power x. So the 1, e power 0 is the same as 1. So I want to solve for x, I have to make sure that the bases are the same. So the 1 can be written as e power 0. So if the same bases, then the powers as well can be equal to each other. It means that x should not be what? Should not be 0. So it means that my domain for this function can be anything except for what? 0. So x is not equal to 0. You can have any value of x but except for 0. That's what it means. So I'm going to have my domain to be x member of from negative infinity to 0. You jump from 0 to positive infinity. This is our domain for the function given. So with that said, you can work on the c part, which is a logarithmic function. I'm sure the c, you've seen that the c is also a log function, the d is also a log function, and the e is also a log function. So your task which you can do, which you can submit, let me just erase this code. So task, we should do B. Sorry, B we've done. So do C, which says find the domain for log 5x minus 3. D, find the domain for log of 2, the absolute value of t plus 4. Just a comment on this one. This is an absolute value which is in the input, and through the same rules we've been looking at, we've been saying that whatsoever is in the input should not be negative or should not be 0. It means that everything in the input should be greater than 0. So the input here is the absolute value. So it means that this will be an inequality. When you'll be solving, you're going to have the absolute value of t plus 4 to be greater than what? 0. So use the properties of absolute values. Use absolute value notes to solve this one. To solve this, I'm sure you can recall we have all the notes on absolute value inequalities. So use the absolute value notes to solve that. And then the last one, it is E, which says log of 5. This is t over 7 minus t in the input. This is just the same as the one we solved in A. So shouldn't stress. As well, send us those 3 solutions. Yeah. Thank you very much, and see you in the next video.